Hi, my name is Leah Vader, and I'm a serverless solutions architect here at AWS. So today, we're going to talk about serverless governance. So we're going to cover how to take a proactive approach for both your developers and your serverless resources. In addition to proactive governance, we'll also talk about continuous monitoring of your resources. And finally, we're going to talk about how to ensure the integrity and validity of the code that you deploy. So first, let's cover how the shared responsibility model changes in serverless. We'll take a look at the Lambda shared responsibility model as an example. So it is true, in serverless, you have a lot less to do, but you still have some responsibility. For Lambda, AWS manages the underlying infrastructure, the foundation services, and the operating system and the application platform. However, you're still responsible for things like the security of your code, the storage and accessibility of sensitive data, and properly configuring identity and access management for your applications. So you're probably already aware of this, and you're probably already building standards or working to build standards around this. And so common standards that organizations build are things like identity and access management, tagging, logging, monitoring, and observability, your network boundaries, encryption, and TLS requirements. But how are we actually doing these, are we actually doing these things? How do we ensure our developers are conforming to these standards? So first, we'll talk about some mechanisms for your developers. Now, this is a 300 level talk, so you're probably already aware of IAM policies, but there's a few key points I want to cover. So we have principals, and these are your users, groups, and roles. We have actions, so these are the API operations that they're allowed to do. We have resources. This is the ARNs, the Amazon resource names. And we have conditions. These are to ensure that specific conditions are met. So let's start with a very generic policy for a user that needs to deploy Lambda functions. So they're allowed to create function and update function configuration on any resource. Now, please note that you do need a few more permissions to create a Lambda function, like IAM permissions, like pass role, but we're going to focus on just Lambda right now. So we can make this a little more fine-grained. And to ensure that our developers are following our standards when creating functions, we can use things like conditions. So these are the supported condition keys for Lambda. So we have function arms, which can restrict the access to a specific function. We have layers, so we can enforce a specific layer that is used when a function is deployed. We have principal, so this restricts AWS services or accounts that can invoke. But recently, we started supporting VPC IDs, security group IDs, and subnet IDs. So what this means is that when create function is called, you can create a condition that enforces the function use specific VPC IDs, specific security group IDs, and specific subnet IDs. So let's take a look at a policy using conditions. So this is the same policy we had before, and it's applied to our developer, Sam the squirrel. And so Sam Squirrel can create function and update function configuration. But this time we've added a condition for specifying Lambda layers. So Sam, our developer, can create function as long as this particular layer called reinvent hyphen, or anything that starts with reinvent hyphen, is applied. So what about managing across our entire organizations using things like AWS organizations? So we can take the same concept of conditions and apply them in service control policies. So you can take a service control policy and apply it to an organizational unit or an OU in AWS organizations. So in this case, we are using Lambda create function and update function configuration, and we're doing explicit deny. And the condition here is if the string is not equal to these VPC IDs. Now use this with caution because SCPs apply to all users in these accounts within that OU that you've applied it on. So use with caution. So we talked a little bit about our developers. Let's talk about some of the mechanisms for serverless applications. We can cover the Lambda permissions model first so we can understand the roles. So the Lambda permissions model has two different functions or policies and roles. We have the function policy, which is a resource policy. Ultimately, this is answering the question of who can invoke my Lambda function. On the execution role, this basically answers the question of what can my Lambda function do? So Lambda assumes this execution role using the trust policy, which will allow Lambda to assume role. And then there's an IAM policy attached to it, which gives it the permissions to call DynamoDB, S3, or whatever your application needs to do. So here's an example of this policy. So of course, at the bottom, we have our trust policy, and this allows Lambda to assume the role. Now at the top, we have our IAM policy. So this is specific to DynamoDB put item. That's the only action we can do. And on this very specific resource, which is a specific DynamoDB table called reinvent. So this is a reasonable policy. But our developers don't always do this. In this case, Sam the squirrel, our developer, allowed all actions on DynamoDB for all resources. And obviously, we don't necessarily want that. So how do I enforce least privilege policies for my developers? So I'm going to talk about IAM permissions boundaries. So there's a few key parts to this. First, your developer will create the IAM permissions policy that they're used to creating. And me, as an administrator, I'm going to create a permissions boundary. This is another policy, but it defines the maximum permissions allowed. And when the execution role is created, we'll have effective permissions, which is the intersection of these two policies. So IAM permissions boundaries allows us to scale permissions management to our developers safely. So it doesn't grant permissions, it defines the maximum permissions that can be granted. It attaches to users, roles, and groups. It doesn't attach to resource-based policies. So let's take a closer look at this. So we grant Sam, our developer, the permission to create policies and roles. And we require that permissions boundaries are attached to the role that Sam created. The effective permission of the role is the intersection of those two policies. So in this way, we have maximum permissions of the roles that Sam creates. So the roles are bounded. So let's take a closer look at permissions boundaries. So I've got an example here. So Sam has permission to create policies and roles, creates the role, attaches this boundary. So this is just a very simple example. And all this is saying is for maximum permissions, we can do anything in terms of CloudWatch logs, create log group, create log stream, and put log events. That's important because Sam is creating this role for a Lambda function. That Lambda function is going to need to log. But in addition to, that Lambda function also has full actions on any Lambda function in US East 1 that starts with the name reinvent, and any DynamoDB table that starts with the name reinvent. So we're only restricting resources here for max permissions. So how do we require permissions boundaries for our developers? Well, it's a condition. And it's applied to principal actions. So if I create role without this permissions boundary, my create role will be denied. So as long as I add that permissions boundary, it will be successful. So the end user experience for your developers doesn't change much. They still create the role. What's different is they attach the permissions boundaries. The identity-based policy and attaching that's still the same. Now your developers are likely working with something like AWS SAM. So here's an example of that. I'm creating a serverless function here. I'm creating a policy and role. And then at the very last line, you can see my permissions boundary that I'm attaching. So we just covered developers and the developers deploying applications. What about our specific resources? So one thing I was hearing from customers is they had applications running in VPCs that need to call the Lambda API. So what would happen is these applications would go make calls out the internet gateway or through a NAT gateway if they were in private subnets. And that would be the only way to reach the Lambda API. Recently, we launched VPC endpoints for Lambda. So now these applications running in private subnets can access the Lambda API using interface endpoints without having to use NAT gateways or an internet gateway. So you can call things like invoke or create function from a private subnet. And since these are VPC endpoint policies also apply. So here we've got a sample, and we're just showing that you can call only Lambda invoke function, so you can't call create function, and only on specific resources. And these are functions that start with reinvent. We're also specifying a specific principal too. So this adds another layer to ensure only the applications we want can call the functions or API operations that we want. And more resource questions that I get is, how can I control access to my private Amazon API Gateway APIs? In other words, limiting to a specific VPC. So that can be done via resource policies. And you can enforce a specific VPC via these resource policies, like this example. So we're doing explicit deny if the string is not equal to our specified VPC IDs. So once again, this is another layer to ensure that only resources from specific VPCs are allowed. Now moving on to our code and ensuring the validity and integrity of the code that we're running in our serverless applications. So we just launched code signing for AWS Lambda. So this ensures that the code packages are not tampered with within your CI/CD pipelines, and that only authorized publishers can deploy code to the Lambda functions. This could be individual teams or platform and operator teams responsible for driving security. You can configure signature expiry and revoke unauthorized signatures. You can set your code signing config in Lambda to either reject or alarm, meaning write to CloudWatch, on signature validation failures. So there is a console experience for this, and I've got a couple screenshots there for you. But this is a governance talk, and so I'm assuming you don't want your developers creating resources in the console. So in the examples later, I'm not going to show you the console. I'm going to show you the API calls and infrastructure as code, so CloudFormation and SAM. But a little more background. Code signing for Lambda is supported by another service called AWS Signer. So later when I show you how to set this up, you'll notice we're making calls to both AWS Signer and Lambda. So AWS Signer is a fully managed code signing service that allows customers to generate signed code packages. So you're going to create a signing profile. And in that profile, you can create permissions for cross-account use. And it allows you to revoke signatures for individual jobs or for all jobs created by a signing profile version or jobs created within a certain time frame. So first, let's step through how code signing works, and then we're going to step through how to set it up. So we make a create function call, and the Lambda service first does an integrity check. If this code has been tampered with, the deployment's rejected. If not, we do 3 more checks. So we do a source check, verify that the code's signed and allowed by a signing profile that we've specified. This is using AWS Signer. We make sure the code signing job has not expired. And we make sure the signing job or the profile that was used has not been revoked. And this is all with AWS Signer. And if that's successful, then the deployment is successful. If not, then we go off of your configuration on whether we enforce and reject the deployment or we warn and write to CloudWatch. So let's step through how to set this up. So first, with AWS Signer, we need to create a signing profile. So the API call for that is put signing profile. And we're going to specify a platform ID. There's one specific for Lambda, and a signature validity period. And the default's 135 months. So in CloudFormation, it looks something like this. So our resource type is AWS Signer, signing profile. We specify our platform ID. I have a signature validity period of 365 days in this case. And I'm also adding tags based off of my tagging policy. So step 2, now that we have our profile set up, we're ready to create a signing job. So the API call for that is start signing job. And this is calling AWS Signer. So we first need an S3 bucket. And this S3 bucket needs versioning enabled. So we're going to specify our source bucket, our Lambda function zip file, the key, and then the specific version for that. Then we're going to specify our destination bucket, where we write the signed code. So we're going to give it the bucket name, and also we're adding a prefix here. And then lastly, we're going to specify the signing profile that we just created in step 1. So we're going to submit that. And in response, we're going to get the job ID and the job owner, which is the account ID. So now that we've created the signing profile and we have our signed code package, we need to go to Lambda and create our code signing config. So this is where we can specify who our allowed signing profiles are and the validation policy for deployment. This is whether we warn and write to CloudWatch or enforce and reject. And in CloudFormation, it looks something like this. So the resource is AWS Lambda code signing config. I'm going to specify the ARN of my signing profile, and that's what I created in step 1. And now I'm specifying my validation policy, and in this case, it's enforce. So we created our signing profile, we have a signed code package, and we have a code signing configuration in Lambda. Now we're ready to create our function. So we can make a create function call and pass in our code signing config. And if you're using SAM, it would look something like this. You can specify on that last line there the code signing config ARN, or in this case, a reference to. So let's tie this together with SAM. So SAM does make this easier. You don't need to call AWS Signer to create a signing job. When deploying with SAM, whether you run SAM deploy or package, SAM creates the signing job for you, signs with the signing profiles you specify, and deploys the function with the code signing config that you specify. This is all infrastructure as code, so it can be implemented in your deployment pipeline. So how do I ensure that my users use code signing? It's a new condition in IAM. So just like we talked about before with other conditions, you can now specify code signing config as a condition. And just like in this example, we're specifying a very specific code signing config that they must use if they're going to run create function. We also have a few more operator controls. So I just covered the IAM condition keys, but we also have config. So config can detect functions where code signing may be disabled or doesn't have a desired validation policy. And CloudWatch has metrics to track signature validation errors per function. And CloudTrail can audit signature details, signature validation errors, and signature status. And you may be thinking, so we've created some new API operations, and I need to know what to allow or deny my users in the IAM policies. And so I've listed them here and separated them by control plane type calls, where we have like create, update, delete, put, and our read-only on the right-hand side, where we have the list and get API operations. So let's move on to continuously monitoring your configuration. We talked about everything that we can do proactively, but we also need to be reactive as well. So we can use AWS Config for this. So AWS Config can act like your configuration auditor, and it starts recording changes of your resources over time and evaluates the configuration against policies defined using config rules. So on the right-hand side, I have an example of my config dashboard. And you can see that I have some rules that have some resources that are out of compliance. Like I have a Lambda concurrency check, and I have some Lambda tagging that is out of compliance, and I have a lot of resources there. So I can use config to alert me, also to remediate any non-compliant issues. So let's talk about how config works. So we have our changing resources over time. When you first enable config, it discovers the supported AWS resources that exist in your account and generates a configuration item for each of those. And with config rules, config continuously evaluates your AWS resources for your desired settings. And depending on the role, config will either evaluate periodically or when there's some sort of configuration change. And each rule is associated with an AWS Lambda function, which contains the evaluation logic for that rule. So config rules will call AWS APIs to do described calls, and then can send notifications to SNS topics. And Event Bridge can also receive events on compliance changes, as an example, and then you can remediate through Systems Manager automation. So we have some managed config rules that you can use out of the box. So earlier you saw we were using the Lambda concurrency check, but you can also use things like Lambda function settings checks to make sure that you can set like specific timeouts and memory settings, or potentially the Lambda VPC check too, if you have compliance rules around Lambda functions that need to run in the VPC. Alternatively, we have API gateway config rules, like a common one is API gateway endpoint type check. So if you have microservices that need to always have a private endpoint, you can use this rule to ensure that that stays in compliance. And if the managed rules don't have exactly what you want, you can create your own custom rules. And we have some examples on GitHub. You can either take these and deploy them as is, or you can take them and alter them to what works for you and deploy. So key takeaways. Use conditions to ensure that your developers follow your org standards, and configure permissions boundaries. Also use VPC endpoints and policies where appropriate. And make sure you enable config and use config rules for reactive governance. So everything we mentioned up front with standards that you want to create as an organization, you can do with AWS Config and config rules, like enforcing authentication, encryption, resource policies, logging, alarms, etc. And then to ensure the validity and integrity of the code you deploy, use code signing for AWS Lambda. So thank you so much. I hope you learned something about governance for your serverless applications. And please complete the session survey. Have a great day.